All right, so we're doing height problem equations, or we call them throw-up problems because we're going to throw balls or drop them. All right, or objects. Could be a person, too. All right, rounding answers to the nearest hundredth is to decimal places to the nearest 0.01. When an object's dropped, its speed continually increases. Therefore, its height above the ground decreases at faster and faster rate. The height in feet of the object t seconds after it drops can be modeled by the following function. Because you keep speeding up, that's why it hurts so much to fall from a high point, okay? And it's much more dangerous than falling from a low point because you're not picking up all that speed. So that kind of makes some sense too, right? No jumping off things. All right, where h sub 0 is the object's initial height, and you don't have to write this, it's right there, but just so you know, that's what it is, initial height, where you started from, okay? All right, and then that next negative 16 I already mentioned is about the force of air resistance is negligible. This negative 16 is really about gravity. All right, Niagara Falls in New York is 167 feet high. How long does it take for water to fall from the top to the bottom of Niagara Falls? And remember, everything falls, if you drop something light and heavy, they still hit at the same time. Okay. All right, unless the wind resistance had an effect. Okay, so we're going to put in, what would this be? 167 would be the initial height. H sub 0 is 167. We're going to find out how long it takes to hit the ground. So what's the height when the water gets to the bottom? What's the height there? Yep, h is 0. So if we plop those into this equation, we'd have 0 equals negative 16t squared plus 167. Now, we're going to go ahead and solve that algebraically right now. We're going to subtract, sorry, that's a 167. Subtract 167 from both sides. That's going to equal negative 16t squared. We're going to divide by negative 16 on both sides. And that's looking like it's maybe 10 something. Let's see. Oh, no, but we have to finish it off by taking the square root. So we got because we have 167 over 16 equals t squared. So you want to take the square root, and I'm just going to type it just like that. So I grab my trusty calculator. I get out of that if it's there. And I hit second, x squared, 167 divided by 16. I mean, there's no point in dividing them in advance. Just type the fraction. All right, I've got 3.23, which means that the water hits the ground after 3.23 seconds. That's the answers. You might want to circle it, especially since we wrote a bunch of stuff down. Okay, now we got a tennis ball being dropped from a height of 213 feet, and it's being dropped, so there's no initial velocity that we talked about in my intro before I started recording. Your height, though, when it hits the ground would be h of 0. Your initial height, h sub 0, is 213, and you just pop it into that equation. So 0 equals negative 16t squared plus 213. So we're going to subtract 213 and divide by negative 16. That'll be 213 divided by 16 equals t squared. Now, I just jumped right to the positive answer because we know it's negative. We're going to subtract and divide by a negative, and we'll get a positive. So we need to take the square root of 213 divided by 16. Okay, please do so. What do you got? 2 what? 8? 3.6. Oh, so what are we going to round? 3.65 and then a 7? Okay, it's very difficult. I just had students talking at the same time, and I could never get what anyone was saying perfectly. So I'm going to go look it up or type it in myself. Can we say that again? What was the decimal? Okay, which would round to 3.65 seconds. Are we good now? All right, fabulous. I'm going to get my key out, though, because I'm not going to have that happen again. All right, so a stuntman working on the set of a movie is to fall out of a window. Oh, Okay, so he's in a window that's 100 feet above the ground. Sometimes I like to make a little picture. So here's your little man. He's about to jump out the window.
Yeah.
Okay. All right, but for his safety, an air cushion, 26 feet wide by 30 feet long by 9 feet high. It's 9 feet high. Okay, is positioned on the ground below the window. Okay, so he's coming out the window. All right, he's going to hit the cushion. How many seconds will the stuntman fall before he hits the cushion? All right, when you graph a height of an object over time, the graph will look parabolic. Okay, so he's coming off and he's going boom, and he's hitting that cushion. That's kind of what it would look like on a graphing calculator. What is his height? How high up is he actually, though, from the cushion? Okay, so we could do that, or we could say, I'm going to tell you two ways to do this problem. So first off, we are going to use the graphing calculator to check it out. This one, though, has not got any velocity on it again, so I really don't have to do that. But the height, if I did it without the man taking into account that cushion's 9 feet above, this would be the equation. But what height? How high is he going to be when he hits? So that's like you could pop 9 in right here, and then you could subtract 9, which is how what you were already thinking possibly, that this height he's got to drop is actually 91. All right, so we're going to say his height will be negative 16t squared plus, and we're going to subtract, that's actually 0 now, 91. We could subtract 91 and divide by negative 16, which is what we got on those other problems. So we're just going to be doing the square root of 91 divided by 16. Okay, I'm going to finally get my page to where I need to be in here. When I did it, I got 2.38. All right, 2.38 seconds. All right, we'll need to be using the graphing calculators shortly when we get to the ones with initial velocity in them, because they can't be solved algebraically like this, unless we knew the quadratic formula, which can solve any quadratic. A movie camera operating at a speed of 254 frames per second records the fall. Oh, so it's that many per second. We found out it took him 2.38 seconds to fall. So how many frames would be in the film? How are you getting that? 2.38 times the 254 frames a second. Okay. Actually, it would come at 605, I think you're getting. You'd have to round up regardless of the decimal. Can't have part of a frame. Okay, so if you actually had typed, though, this and not rounded it, it would come out to 606, but that's fine. All right, now our objects. It says for an object that is launched or thrown, be a rocket launched, an extra term v sub 0 must be added, which stands for the object's initial velocity, the amount of speed that got put on that object. It is not a constant rate of change. It will decelerate as it falls. So we got a dropped equation, and we've got a launched or thrown equation, which adds in the initial velocity. Okay, and you got your h sub 0, initial height, h for your height, and t for your time. All right, explain why the height model h equals negative 16t squared plus initial velocity times time plus initial height applies not only to launched or thrown objects, but to dropped objects as well. If dropped, what would the v sub 0 be, the initial velocity be? The v sub 0 is 0. So the v sub 0 times t would drop out. And that would give you h equals negative 16t squared plus initial height. right, number 5. Let's get over to some problems. I really like these. It gives you a real purpose for all this parabola stuff. Besides maximizing sales, and that's another application we discussed. A baton twirler tosses a baton into the air. Okay, so she's, or he is twirling and throws the baton into the air. Ooh. Okay, the baton leaves the twirler's hand 6 feet above the ground. Oh, her hand is big, long. Okay, so anyway, that's 6 feet. I know why I'm drawing it. I really don't need to. H sub 0 would be your 6 feet. Let's pick this word problem apart. And she's putting some speed on it, 45 feet per second. Initial velocity is 45 feet per second. The initial height, we said, is 6. The twirler catches the baton when it falls to a height of 5 feet. How long is the baton in the air? Well, we could let H be 5, and then we could pop all that into the equation, but I'm going to show you how to do it another way because I want to teach you how to find the graph, how to do it on the graphing calculator using intersection. I'll show you what I mean. So the height is negative 16t squared plus the initial velocity was 45, so we do 45t, and plus the initial height that came out of her hand when at 6 feet. So if I thought about this picture, and I'm thinking about the height over time, she threw it, and then she's going to catch it. Okay, so here is 6, but she's going to then catch it at 5. Okay, so it's only going to go that much of the time. It's never going to hit the ground. So we want to know that. Okay, we want to know how long, and if you let time be your x-axis, then this would be the value of x on your x-axis for how long she had it in her hand. Okay, so I've kind of given you a visual of it, and now we're going to pop it in the calculator. So what we're going to do is we're going to put y1 there for h, and then in y2, we're going to put what height we want it to hit, and that would be 5. Because you can't really solve this unless it was factorable or we knew the quadratic formula. We haven't covered quadratic formula yet, so this is what we will be applying this concept in the future as well to other types of equations. So we're going to put in our negative 16. Use x for your t. Do not use a t. That is something different. Okay, plus 45t, or x. And then what was the initial height? She came out of her hand at 6 feet. On line 2, we're going to put in 5. Now, I need you to think about stuff, what you're going to have to do to be able to see what you want to see. So what I want everybody to do is hit zoom and 6. I need to work on your number sense. I can see where my answer is going to be, and I can also approximate that it's a little bit less than, this looks like it's landing or hitting the ground. You understand this would be hitting the ground because that's where y is 0, which is the height. Okay, so that's about 3 seconds till it hits the ground, but somehow she's catching it here, so it's a little less than 3 seconds is what I'm estimating. So doing an estimation is a good plan, but we need the exact answer to the nearest 100. So we're going to have our calculator help us out with that intersection. So we're going to go second, trace. That is the calculate section. What do we want to find? So read the value. This is the best way to learn it, is to think what one makes sense for me to find right now. Where they meet, the intersection. Okay, so choice 5. Okay, so then it's saying what it's your calculator's asking you, is this the right, is this one of the curves you want me to find the intersection with? And that's yes. So you hit enter. Is that the other one? Shows it right there. Yep. Hit enter. And then enter again for it to get you that answer. Now, what's wrong? Is that the one I want? So why is this bad? Because I'll have kids who will write down. It's negative. What is this about? How long it took, okay? We are not going back in time. I haven't learned how to do that. Okay, so let's try again. So if yours did that, yours might not have done what mine did. but I wanted you to understand why you are not going to select that choice. So second trace, I'm going to go back to intersection, and then I'll see my little cursor thingy. I want it on somewhere else, so I'm going to arrow it over. Oh my gosh, it disappeared. How come? Oh no, and then it flashed right past me. Okay, so how could we make this look better? What would we have to adjust? Something about our, what do we call this thing? This is the window. Okay, so we could fix it so we could see a little bit better. We don't have to do this problem, but I'm just saying if you wanted to see the whole graph. Do I really care about the negatives? Not really. So I'm going to change my x min and my leave that at 0, and then I'm going to go to the y's, and I'm going to say, well, I got to go higher. So I need to change the y maximum. Okay, I want this to make sense, guys. Why I'm picking, I want the y to go higher. All right, so I'm going to put in, I don't know, 40. You can put in 25. You can put in something different than me. You don't have to have what I have. And you can always adjust if that's not a good idea. Oh, now I can see. You could find out how high it reached by finding the vertex right up here, which is the max. And you could also find now how long it took till she caught the baton by hitting second trace, calculate the intersection, choice 5. If your cursor isn't visible, you can arrow until you see it, but I think it's just asking me the curve. I'll hit enter, 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 see. Oh, all right, it got it for me, 2.83. Anybody have a problem getting it? You should see 2.83, blah, 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 and 5 for y, which is exactly what we wanted. All right, so we're going to do a couple more of these. If it didn't work out great for you this time, don't worry. We'll work on it again. All right, so the time was 2.83 seconds till she caught the baton. Oh, I got something in my way here. All right, let's hit number 6. You and your friend are playing tennis. Your friend lobs the ball into the air, hitting it when it is 3 feet above the court. Okay, 3 feet above the court. That's when the person hit the ball. So that's going to be my initial height. An initial velocity, v sub 0 is 40. You back up and prepared to hit an overhead smash to win the point. All right, tennis even applies. Things happen fast out there on that court. Even a lob ball isn't up there very long. So write an equation giving the height of the lob tennis ball as a function of time. The height of the ball is negative 16t squared plus initial velocity 40 times t plus the initial height. When you hit the ball, it's at 3 feet. At what time does the ball reach its maximum height above the court? Well, the maximum is, of course, the vertex, and it's the height of that vertex. There's 2 ways I can get it. What time would be the x value of that vertex, or the h, if you will, from our previous studies on parabolas. So if I want to find that, I'm going to use this equation, and I'm going to do the opposite of b, which would be negative 40 over 2 times a, 2 times negative 16. So that's x. X equals negative 40 over 2 times negative 16, which is negative 40 over negative 32. And if you were to reduce that, that's actually divide by 8, and you would get 10 fourths. Oh, I didn't reduce. I could have divided by something more. So that's 5 halves. Is it? No, I put a 4 on the bottom. I can't. I'm not doing this right. I know how to do this. I don't know where my brain just went. Divide by 8, and you will have 5 over what? 4. Okay, that's 1.25 in decimal form, and that would be the number of seconds. Now, the maximum height, you could plug in 1.25 into the equation and do negative 16 times 1.25 squared plus 40 times 1.25 plus 3. The other option is to have let the calculator get this stuff for you. Okay, so I can show you how you could get that as well. But anybody calculate this yet? I don't want to waste time on popping that in because I'm going to pop it in for this one anyway. So that came out to 28 feet. Okay. All right, now the next part. You plan to hit the smash when the ball falls to a height of 8 feet above the court. How long do you have to prepare for the shot? So now we want to know. So I'm going to put in y1 negative 16t squared plus 40t plus 3. And in y2, I'm going to put in 8 feet. And I'm going to find out where they intersect. Bless you. Go to y equals. I can actually change this equation by arrowing over because I know the first part's not changing. What was the initial velocity? 40? Okay, I just wrote right over it. And the initial height was 3 feet. And then down on line 2, I'm going to change that to 8. And then I'm going to graph and see if that window was any good for this one. Oh, yeah, it works fine for that one. Okay, so let's find out how long it took. Looks like it's a little over 2, maybe close to 2.5 seconds. Second, trace. Choice 5. Okay, enter, enter, enter. It's nice having the color graphers because you can tell it just changes the color. You know it's bouncing off one color to the next. And that happened in 2.37 seconds. You got 2.37 seconds to get ready for that smash. I forgot 2.37. Not too bad, I hope. All right. Oh, we're not done with that one. E. Suppose you hit the smash when the ball is 8 feet above the court, and it takes 0.1 seconds for the ball you smashed to hit the court on your friend's side. I think they're just standing there and didn't have much time to get to that one, right? 0.1 second. All right, what was the ball's initial vertical velocity coming off your racket? All right, now we want to know V sub 0. Okay, what do we know? We know the initial height is 8 feet. What's this? 0.1. It's a time value, t. Okay, so let's fill in the equation. So what's the height going to be when it hits the ground on the other side? So our h is 0. Our h sub 0, or our initial height's 8. So 0 equals negative 16t squared plus, I don't know v sub 0. Oh, I forgot to plug something in. I need to replace my t with 0.1. Okay, and I need a 0.1 there, and then I need plus 8 at the end. Okay, go ahead and type on the calculator negative 16 times 0.1 squared plus 8, because those are just numbers. Negative 16 times 0.1 squared. Okay, and then I have to add 8, and I get 7.84. So I'm here, and I have plus v sub 0 times 0.1. Okay, so now I need to subtract, if I could speak, 7.84. And then what would I do to get v sub 0 alone? Algebra, divide. Okay, so negative 7.84 divided by 0.1, you should be getting 78.4, and it's negative, isn't it? Now, you're getting negative 78.4, but that's in feet per second. Why did it come out negative in this problem? Which way are you smashing it? Down. Okay. So if you were talking about what is really your initial velocity, it's not negative. It came out negative because this is being hit down, but your true of your velocity that you put on the ball is 78.4 feet per second. Very fast. Pretty fast. Hey, well, think about, when they're talking about speed, well, that's in miles per hour, right? That's pretty dang fast. I'd like to convert that. Anybody want to do the dimensional analysis on that? Anyway. Oh, we'll be doing it later. Don't worry. We got our time in this class for that. All right, basketball player. Okay, we got a basketball player now.
Yes.
We're gonna draw him. Yep. He is throwing the ball. Okay. Guys. All right. Basketball player passes the ball to a teammate who catches it 11 feet above the court. Oh, this guy's in the air. And he's got the ball. All right. Somebody else passed it to him. I didn't really have to draw this, but just above the rim of the basket. Oh, I made a messy basket. All right. That's horrible. It looks more like yeah. Don't know what happened there. There we go. That's a little better. All right. So then the first player releases the ball 5 feet above the court. So some guy threw it to him, and it was 5 feet above the court at that time. All right. He threw it, and this guy catches it where? How high above the court? Oh, he was 11 feet. Just 11 feet above the court. First player releases the ball 5 feet above the court. Oops, so my H sub 0 and initial velocity of 21 feet per second. So this is my initial height. It didn't even matter that he caught it at 11. It says how long is the ball in the air before it got caught? Assuming it's caught as it rises. So think about this. When the guy threw the ball, it was at 5 feet. And it might have gone higher than that if he hadn't caught it. So it says he caught it as it rises, which means we'll want this value because then he did what? He slam dunked it. All right, so here we go. The height of the ball was negative 16 t squared plus initial velocity 21t plus the initial height 5. Okay, now he caught it when it was at 11 feet. All right, so we're going to put this in our calculator just like that. Let's go back to our y equals. Let's change up this equation. What was it, 21 for initial velocity? And then his height was 5. And then the guy's catching it on the first time it hits 11 feet because this ball, if it had not been caught, might have been at 11 feet at 2 different times. It didn't reach its maximum height. Well, this still will work for me, but I'm not big in that picture. So I'm going to go to the window. I'm just going to reduce this down to 20 instead of 40. Just because I feel like it. And then, whatever. I could have changed the X values as well. But all right, good enough. We want the first one, not the second one. Okay? That first intersection. So what we might want to do, well, let's just hit second trace and see if it's ready to calculate that intersection for me. Choice 5. First curve, yep, that's the parabola. But, ooh, I'm way over here. So I'm thinking it might not give me the right answer if I hit enter, enter. You see how it's giving me the run I don't want? Okay, so what you can do is you can just arrow over with your cursor and get it over close to the point that you actually do want. So you got to know what to interpret, how to interpret which one you need. Choice 5. Enter, enter, enter. Oh, that little stinker. A little stinker. Okay, here, let's do this. Press trace, arrow over. Get on that blue curve over there on the left. All right, try again. Second trace. Choice 5. Now I'm going to do my enter, enter, enter. Okay, finally, I got the 0.42 seconds. Perseverance. 0.42 seconds. I knew what I wanted. I just had to make it happen. Everybody needs this practice, so I hope you are. The only way to get proficient is to be doing this yourselves at the same time. You need to become fluent. Number 8. Oh, something has changed. What's changed? Why is this number not negative 16 anymore? There is a reason. Now we're talking about meters. Okay, so that's all that changed. If the problem's in meters, then you need negative 4.9 there. If it's in feet, then it's negative 16. Okay, John threw a balloon. Uh-oh. Oh, it is a water balloon. Oh, threw a water balloon upward with an initial height of 20 meters and an initial velocity of 10. So there's your basic 0. Okay, write an equation. Shh, guys, please. Negative 4.9 t squared plus 10t plus 20. No different than the other ones, except the negative 4.9. What is the height of the balloon after 2 seconds? All we have to do is substitute in 2 here. Negative 4.9 times 2 squared plus 10 times 2 plus 20. And then how long did it take for the balloon to reach the ground? We're going to need a grapher. So I'm going to go ahead and put it in because I'm going to show you how you can get the 2 seconds in your grapher as well. Okay. Glad it's okay with you. All right. Down to... and it wouldn't matter if it wasn't, but sorry. Negative 4 because I need to do it. Negative 4.9 x squared. Let's see. Our initial velocity, was that the 10? And initial height, 20. Okay, so let's hit graph. Ew. Well, I don't really like that window. I don't know if I'm not going to zoom. Let me see what it looks like if I just zoom 6. Oh my, can't see the top of that thing. All right, so to get the value that you want, I won't do that first. I'll get you to see it better. So wait 1 second. Stop it. Second key.
And then I got to figure out how the hell to do a 3-way. That's another question, but I'll figure that out. And then,
Oh, get out of here. Quit.
and if I can't
All right.
my cell phone, well,
Go to your window, and then, I don't know, did anybody find a good window already? My pen's stuck. There. Oh, there we go. Let's just get the max up. How high? 30 works good? All right. And that's all it does is you practicing and testing numbers is how to tell if it's good or not. All right, I'd like to know, it said, I forgot the question now because it's taken me so long to get here. It said, what is the height of the balloon after 2 seconds? All right, let's do that first. I know you could have just substituted in 2 for t, but you also can get this, the value, by putting in 2. And here's what you do. You go to second trace. What do we want? We don't want a 0. That's where it x-intercepts. We don't want a min. We don't want the max. We want a value of 2. So that's choice 1. You pop in 2 and hit enter. And there it tells you 20.4. Okay, so this should have come out to 20.4 meters anyway. How long did it take for the balloon to reach the ground? We'll go right back to our graphing calculator. And we want to know this time right here, so we need to know the 0, which is the x-intercept. Second trace, trace 2, because that's where h, you actually could put a value in of 0, but it wouldn't necessarily give you the right one, and we want the one on the right. All right, so enter. I guess 2 is a good number, and 4. I'm just going in between there. 3.28. Now let me try doing that. So I'm at second trace. I'm going to put in a value. Oh no, I can't put in the value for y anyway, so never mind. We're done. 2.83. Oh, sorry, what was it? 3.28 seconds. Oh, I had the numbers, but I transposed them all over. All right. Okay, now Shizuko threw a stone. Uh-oh, hope nobody's in the way. Upward at a speed of 10 meters per second. Oh, I see meters, then I know I need to do the negative 4.9 t squared problem. Plus, wait, he threw it though. Oh, is that 10 meters per second? That's my v sub 0. We're at 10t, and he's on a cliff. That's kind of a weird thing to do, but 40, you throw it up in the air off the cliff. Okay. What was the height of the stone after 3 seconds? Of course, you can pop in 3 for t. And get the height. And how long before it hit the ground? So I'm not going to type that in my calculator. I'm going to go put it in the grapher. Because I have to anyway. Unless I know the quadratic formula. So I'm going to change up these numbers. What was his speed he put on there? It was 10? Okay. I already have a 10 there. I was surprised. And our cliff was 40? Okay. See if that works for a graph. Oh, I don't really care if I see the top that much anyway. So let's just go ahead and do it. So hit second trace. We're going to put in a value of 3. And what we should get, if we calculated that, was 25.9 meters. Go back. And now I want to know when it hit the ground. Second trace. Trace is the 0. Enter, enter. Oopsie, I didn't put a number in. I forgot to tell you that I am not going to get the right answer from this because I have a bound error. If you ever get that, just say quit and get out of there. Try again. Or just sit second trace again. I'm going to find the 0, choice 2. Now, maybe you've forgotten what left bound, right bound means. Left bound means you could pick an x value to the left of it, or you could be to the left of the point. So it is okay for me to hit enter right here, but let me show you what you'd have to do. Most of the time, I think it's better if students look and they say, okay, it's between 3 and 5, something like that, and do 3, enter, 5, enter. Or let me show you how you can do it without entering numbers. You could hit enter right now because it's above the intersection at the of the x-axis, and then you would have to keep cursoring till you get below it, which I am below it. I'll just show you that I am. You could hit enter again, and it can be found like that. Okay, 4.05 regardless. 4.05 seconds is to the nearest 100. Okay, so I'm going to stop here. Read the problems carefully. If it's dropped, you can just use the simplified equation. If it's thrown or launched, you need to use the one with initial velocity in it. And check if it's in feet or meters. All right, you have some problems on the next side, or whatever this side is. What side are we on? Are we on 10B and B? 16A? Okay, so you got 16B and 17 with height problems. Get working on that.